Welcome back to another episode of Coding with Culp. Today we're going to have some fun. We're going to learn the basics of Python programming using a package called Turtle Graphics. We're going to make some really interesting shapes and patterns like the one you see over here on the right. Now, Turtle Graphics is a programming package or graphics package modeled after a language called Logo. Logo was originally made in the late 1960s. I want to say like 1967 at MIT. And it was modeled on a language called Lisp, and in fact the very first implementations of Logo were in fact written in Lisp. But what it was done for was to essentially teach children programming. And Python, and it was really popular in the 70s and 80s. Anyways, Python has a package called Turtle Graphics, which replicates some of the commands of Logo. And the reason why it's called Turtle Graphics is that the original Logo had a little turtle on screen, and that turtle would then trace out patterns, and actually so does this one, and trace out the patterns as they were drawn. And later on there were actual turtle robots that drew it out on paper. So anyways, without further ado, let's take a look at our learning targets, our learning goals, what we're going to do today. Alright, so by the time we're done, I want you to be able to learn the basic structure of a Python script, learn how to import the turtle module, learn how to start the turtle module, learn the basics of turtle drawing commands, learn the structure of a Python for loop, so we're going to be doing some looping, and then learn how to write and call a simple Python function. So without further ado, let's get to writing some code. Alright, I'm going to be using a Raspberry Pi for this. I love the Raspberry Pi for learn how to code, especially with Python, simply because everything's absolutely set up for you. You don't have to worry about installing Python or installing an integrated development environment or getting it up and running. It's all done for you. We're going to be using a code editor called Genie. So on Raspbian, I just click up here, go to Programming, and go to Genie. Alright, I already got a bunch of turtle programs written because I was experimenting with it. Let me go ahead and end all of these. So what we're going to do is we're going to go File, New. We're going to create a new file. Now my Genie is going to look a little bit different than yours. I've got a dark background. I think it makes it a bit easier for you to see as I type out. Alright, the first thing we're going to do is we're going to import the turtle module. Oh, let me also save this. So I'm going to go File, Save As, and let's come over here to my coding directory right here, and I'm going to make a new folder. I've already got a turtle folder. I'm going to call it Learn Turtle. You can call it whatever you want. In fact, I recommend you probably just call it Turtle, but I'm going to call it Learn Turtle because I already have a turtle folder. Click Create. Alright, so for the file name, I'm going to call it Turtle1. Do not call it turtle, by the way, .py. Just call it turtle1. So the reason why I don't want to call it turtle is that the name of the package we're going to be importing is turtle. And if we called this turtle.py, there's a chance that Python could get confused. So we're going to call this turtle1.py. You can call it whatever you want, just don't call it turtle.py. So I'm going to click Save. Alright. So we're going to import the turtle module, and we're going to import the random module. We're going to need random here in just a bit. And what these two lines of code do is they essentially import packages that we can use. They import code that somebody else has written, and we can call on those functions or that code that's inside there. So this imports the turtle module and the random module. Okay. First thing we've got to do is we've got to set up our turtle module. So let's get started with that. I'm going to do a little comment. Okay. So what this does right here, this hashtag, it makes a comment. A comment is something that does not get executed. It's for us. It's, so we know what's going on. When we come back later on and take a look at our code, we'll know what's happening in there. So first thing we're going to do is we're going to set up our turtle module. And we're going to make a couple of variables. I'll explain these in just a minute. And there's various different ways you can do this, and if you went and looked at different people's code online, you'll see different ways of doing this. This is just one way to do it. Let's see here. Let's do black for our background color. Once again, I'll explain all this in just a moment. It's hard to type with this mic here in front of me and my keyboard out in front. All right, so what we do here is we're going to declare a variable called it when, and what we do is that's going to point to our screen, and we can do various things with that, like set the background color, and that's what this does, when.bg color. We're going to set it to Balak. Ooh, that's not right. We're going to set it to black. The turtle module allows us to use just regular strings for colors like black, red, yellow, green, blue, pink, etc. Not every color is in there. For example, I don't know if chartreuse is in there, or I don't know, fuchsia or something, but you can look up the colors. In fact, I'll see if I can remember to put a link down below to a website that'll tell you all the colors you can use. Then when.title sets the title of the screen, of the bar that you'll see at the top. We're going to call this Hello Turtle. What this does, when.color mode 255, is it's going to allow us a different method of addressing colors. As you'll see in just a bit, I'll explain it when we get to it. And then this right here, T, sets a variable called T, and it's going to hold our turtle object that we can control and move around. And this sets the speed of that turtle object when it draws on the screen. As you'll see, you can go from really slow to fairly quick. All right, let's do our first drawing. Let's do this. Start drawing. We're going to set our pen color. We're going to set it to red. So we're going to be drawing in red. And so let's do this. Let's go forward. Yeah, let's do that. So let's make a box. Okay. So T dot forward 100. All right. And then I think at the very end we've got to do, is it T dot done, turtle dot done. All right, let's see if this works. And it did. It might have an error here. Turtle object has no attribute done. Oh, I know what I got to do. Turtle dot done. There we go. So let's explain what happened. We set up all of our turtle module stuff. When.bg color set the background color to black. When.title set a title of our screen to Hello Turtle. Once again, this color mode, don't worry about that right now. I'm going to explain it later. We set our turtle speed to 10, which is the fastest. We set our pen color to red, so we're going to draw in red, as you can see. And then we just said, hey, go forward 100 pixels. Now let me explain the coordinate system for turtle graphics. This point right here in the dead center is 0, 0. So I told it to go forward 100, and so it went forward 100, this direction right here. Let's make a couple quick changes and see what happens. Let's go backward. Should be T dot backwards. And let's use a different color. Let's see if we can do purple. And let's change our window title. Hello turtle. Hello purple turtle. And there we go. So he went this direction. Okay, went backward 100 pixels. All right, let's go back to red. Oh, I wanted to show you one last thing. We can actually state the color in a different way. We can use 3 numbers for the color. And I'm going to show you what I mean by that. We can tell it the amount of red, the amount of green, and the amount of blue that we want. Each number goes from 0 to 255. So this right here should say, hey, maximum amount of red, but no green and no blue. So we should be back to drawing in red. And we are. You can actually, if you're using Genie, if you click this right here, it's a little color chooser. And so let's pick, oh, I like this kind of purple here. So what do we got here? 253 and 235. So red's 253. Let's go 255 for red, and let's go with 235 for blue. And when we do that, sure enough, we get that kind of purplish color. And in fact, this is how I'm going to be working with colors from here on out, is with that red, green, blue triplet. Now then, because I don't like typing out the words backwards and forwards, there's actually a shortcut. FD stands for forward, BK stands for backwards. Now watch what I can do here. I can turn, and I think it's T dot left, and I can tell it the number of degrees. In fact, it tells me right here the angle. I need to put in the angle to turn. So let's turn 90 degrees. And you can see it went forward, and now you can see he turned 90 degrees and is now facing up. Let's slow down our turtle. Okay, slow down our turtle. See if we can actually watch him this time. We can't. He's still pretty quick. There we go. I think you saw it that time. He went forward, and then he turned. Okay, so let's think about what we'd have to do to draw a square. He'd have to go forward, turn left 90 degrees, then go forward again, turn left 90 degrees, go forward again, turn left 90 degrees, go forward again, and turn left 90 degrees. So you'd have to do that 4 times. Well, let's give that a try. Rather than typing it out 4 times, I am going to just simply copy and paste. So there we go. That should be number 1, number 2, number 3, and number 4. And by the way, there's also a right, so you could go right if you wanted to by number of degrees. And let me clear off. I always forget to do this with Genie. I forget to clear off the old terminal windows. All right, here we go. And there we go. Perfect. Absolutely perfect. And like I said, we could actually go right if we wanted to. Oh, by the way, there's a shortcut for left and right also. LT and RT. LT and RT. Okay. So now he should go. Yep, goes right. So that's great. The problem is we don't want to, if we wanted to draw a square, let's say we want to draw a square 4 or 5 times. We don't really want to have to type this out each and every single time. Wouldn't it be great if Python had a way to loop or just do these 2 statements right here 4 times so we didn't have to type them out each time? And the thing is, Python actually does have that ability. In fact, just about every programming language in the world has the ability to do what we call loops. So we're going to do 2 different types of loops real quick. First loop we're going to do is called a for loop. And it looks like this. For x in, actually I'm going to call this I. For I in range 4. Notice that colon right there. And then, okay, I need to indent these two lines. I'll explain why in just a minute. But what's going to happen? This is called a for loop. And it's going to do this for loop 4 times. Each time through the loop, I is going to get the value or the iteration number through the loop, starting at 0. That's a big thing, though. Starting at 0. So it's going to go 1 time, 2 times, 3 times, 4 times. And once it's gone 4 times, it's going to exit the loop and then do the stuff after the loop. Now, notice the colon. The for loop has to end in a colon. And also notice that I have indented this stuff. The for loop will do everything that's indented after the for loop. And in fact, notice Genie makes a line here. And basically what this line does or says is, hey, all this stuff right here belongs to the for loop, and it's going to get executed in that for loop. And in fact, I can even collapse the for loop if I wanted to. Okay, let's run it. Oh, I got an error. Syntax error. Invalid syntax. Well, that's weird. All right. Oh, oh my gosh. All right, I see what I did. For I in range 4. There we go. I feel stupid now. There we go. And it does exactly the same thing. Only it's a lot more efficient because we don't have to type out these 2 statements 4 more times. And I'm going to go back with doing a left, just personal preference. Now, one other thing I want to do is I want to print out the value of I as I go through the loop. Doesn't have any bearing on our program. I just want to demonstrate something. And once again, let me get rid of these terminal windows from Genie. All right. Notice how it prints out 0, 1, 2, and 3. So in a for loop, what happens is I, this counting variable or iteration variable, gets the value through range. So the first time it's going to be equal to 0, and then 1, and then 2, and then 3. Notice it never got to 4. That's a big deal, big hang up that many new Python programmers have. Okay, it's going to start out at 0. And it's going to go to 1 short of this value right here. So it's going to go 0, 1, 2, 3. In addition, we don't have to start at 0. And just in case we wanted to, let's say, start out at 5 and go to 9. Okay? So we're going to start out at 5. We're going to go 5, 6, 7, 8. But once again, we're not going to get to 9. Now it's going to do exactly the same thing again. Exactly the same thing. And it's going to print out 5, 6, 7, 8. But it also draws a square. Because in reality, in our loop, we don't care about the value of I here. Sometimes we will, but this time we don't. All right, there's another type of loop called a while loop. We're going to do that real quick. So I'm going to set a little variable. I'm going to say, let's say I equals 0. And I don't want it to be in capitals. I accidentally hit the caps lock here. I equals 0. And we can say while I is less than 4, go through the loop, and we're going to put I equals I plus 1. Let's run it now, see what happens. Exactly the same thing. So let's talk about the while loop. The while loop is another looping structure. Allows us to do things over and over again. And what the while loop does is I make a variable. I make basically a box in memory that I labeled I, called it I. I could have called it actually anything that I wanted to, as long as these are the variable naming rules in Python. Number 1, that it begins with either an underscore character, or that's not an underscore character, or a letter. Okay. For example, I could have called this Luke Skywalker if I wanted to. Now, the other thing is the variable name itself can only include numbers and letters, or underscore characters. No spaces, no special characters, etc. So if I wanted to name it Luke Skywalker, it would have had to been all one word or separated by the underscore character. So then what we do is we say, hey, while that variable I, while whatever I holds, while it's less than 4, do these things that are indented. Also, once again, notice the colon. So it's going to go forward, it's going to turn left, and then, this is the magic, it adds 1 to I. So I started out being 0. The first time through the loop, I is equal to 1. It goes back up here and says, hey, is I less than 4? And it sure is, so it does all this stuff again. Adds 1 to I, so now I is equal to 2. Comes back up to here and says, hey, is I less than 4? Well, it sure is, so it does these things again. Adds 1 to I is now 3. So it comes up to here and says, hey, is I less than 4? Oh, it sure is. Does all this stuff. Now it adds 1 to I, and I is now equal to 4. Comes back up to here and says, hey, is I less than 4? And 4 is not less than 4. So that test fails. And so it skips everything that's in the loop and comes back to here, which is turtle.done. I'm going to show you a shortcut for this. We could have said I plus equals 1. That's just a shortcut for add 1 to this variable. I could have called it, I could have done 8 plus equals 8 plus equals 10, whatever. It's just a shortcut for adding to this variable. Okay, so this is awesome. This is great. We're getting somewhere. But what if I wanted to do squares over and over again? And by the way, I'm going to change this to a for loop. Provided I can. Don't want to forget the in this time. And I don't need any of this. Alright. This is great, but what if I wanted to make multiple squares? Alright. And what if in between each one I wanted to turn a little bit? Let's do 17 degrees. Alright, let's watch what happens. There's one square. Now he turns 17 degrees, draws another square, turns 17 degrees, draws another square. Hey, that's starting to look kind of neat. I like that. But here's the deal. Once again, gosh, we don't want to keep doing that. Okay? So there's two things I could do. What I could do, I can nest these for loops. Watch this. I could do another for loop. I could say for j in range, I don't know, I'm going to make up a number. Let's go 30. And now what I can do, I can put this for loop inside of this for loop. So what's going to happen, it's going to say from 0 to 30. So the first time through this loop, it's going to do this 4 times. It's going to draw a square. Okay. Then it is going to, oh, wait a minute, there we go. Then it's going to turn left 17 degrees, go back up to here. Then it's going to do this 4 times, turn left 17 degrees, go back up to here. It's going to do this 30 times. Basically, it's going to do what's inside of here 30 times. I'm going to speed up our turtle, otherwise it's going to be really slow. So here we go. Now we're getting somewhere. This is neat. Probably did it more times than I needed to. Yeah, I like that. That's starting to look kind of cool. However, another thing I could do, it seems like we want to draw squares a lot. We can make a function called square. So what functions are, so to draw a square, we just do this. So I'm going to copy this. Oh, that's indented too much. OK. All right. So let me get rid of this. It might be easier to understand if I do it this way first. What a function is it's a piece of code, a named piece of code, that we can call over and over and over again. We're going to call ours square because, well, that's what it does. It draws a square, so that makes a good name for it. So let's look at the structure of a function. It always starts out with this keyword def, D-E-F. Then we name it. I could have called it anything that I wanted to. I decided to call it square because it draws a square. Now this right here is what we call a parameter. What we can do is we can, when we call it, let's go down to here. When I use it, I say square 100. What that means is that this word right here gets that value, the calling value. And then I can use it inside of my function. So the first time I call square, size is going to be equal to 100. So it's going to draw a square of size 100. Then I could even do it again. And I could do something like square 300. So then the second time that it calls the square function, this word, this variable, this parameter, size is going to be equal to 300. And then when I address it in here, when I use it, it doesn't see size, it sees the number 300. That way I can draw squares of different sizes. Let's run this real quick. So did you see that? It drew our first square at size 100, and then it drew another square at size 300. And I could do another square, maybe at size 150. There we go. So I can call this piece of code over and over and over again as many times as I wanted to. And each time I use it, I will give it a different number, and so it'll draw a square of a different size for us. All right, now let's do something kind of neat with it. Remember how we were drawing that kind of flower shape with a for loop? Let's do that again. For I in range, once again, I don't know, let's call it 30 times. Remember the colon. Square 100. And let's do a left turn. T dot left. And I don't know, let's do 8 degrees this time. No, 7's fine. So here we go. Oh, that looks neat. I like it. All right, very good. In reality, if I want to do a full circle, okay, my range is just 360 divided by however much I'm turning by. So I'm turning by 7 degrees. And so let's do it this way real quick. I want to show you something. So there we go. Oh, no, it didn't work. I know why. But it says, type error, float object cannot be interpreted as an integer. Okay, so here's the deal. Python is expecting an integer in here, a whole number. Okay, a whole number, it could be negative, it could be positive, but it has no decimal place in it. So I couldn't go range 3.5 or 7.82 or 3.14159. But 360 divided by 7 is not an even number. I can force Python to use what's called integer division with the double division sign there. So what's going to happen is Python is going to do this division and force it into being an integer. All right, let's do it one more time. All right, looking good. Now I'm going to show you how to do something. I don't actually like doing this. Don't actually like doing what I'm about to show you because I like watching this being drawn. Only problem is with this video, we don't really have that time. Before we draw, as we set up here, we can issue a command turtle, turtle dot tracer 0, 0. What this is going to do is it's going to turn off tracing and just draw the image for us. And what I've got to do down at the bottom, after I'm done drawing, just before turtle done, I got to call turtle.update, I think it is. Let's give that a try, see if that worked. There we go, it worked. Okay, now let's get even more creative here. Maybe we should have a function called drawFlower. All right, and drawFlower is going to take a size. What else does it need? Oh, and an angle to turn. So it needs a size. It needs an angle to turn. No. I think that's all it needs. Yeah. And it's basically this right here. Control X. Okay. So we're going to divide by our angle. That's going to give us the number of times to draw to go all the way around. We're going to make a square of size. And then we're going to turn by angle. And then let's use it right over here. Let me tighten this up a bit. drawFlower. And so it's size then angle. So let's draw a flower. Let's draw a big one. Let's go 300. And then for our angle to turn, let's do something kind of big. Let's go 35 degrees. So let's explain what's going on here. When it gets down to here, draw a flower. It's going to pop up to here. It's going to put 300 in for size. And it's going to put 35 in for angle. So then right here, we're going to enter into a for loop of 360 divided by angle. So it's going to execute that for loop that many times. It's going to call our square function. We can call a function from inside of a function. It's kind of cool. So we are going to draw. Okay, we're going to draw a square of that size. So what's going to happen when it gets to here, it's going to put that, whatever we put in for size, which in this case is 300, it's going to go up to here now, put 300 in for this size. It's going to draw a square of size 300. Then when it's done drawing that square of size 300, it's going to come back down to here, turn by our angle, come back up to here, do it all again. It's going to keep doing this. Now let's give it a try. Oh, that's neat. I like that. But part of our problem, you know, it's kind of boring. We're always doing the same color. Oh, you know what we could do? Watch this. Instead of just a square, it might be neat to do a polygon of whatever size. So we're going to pass to it the number of sides and the size, okay? And so we're going to do for I in range sides, and when we turn, it's going to be 360 divided by the number of sides. So now we can draw a polygon of any number of sides. What's going to happen, in fact, let's just draw a couple polygons. Polygon. What do you call it when your parrot leaves you? Polygon. All right. So let's do one of 3 sides. That's a triangle and a size of 100. And then let's draw a polygon of 5 sides and a size of 250. So let's see. Yeah, there we go. I don't think it worked. Oh, I think we got an error. Let's get rid of this. Oh, I said 260. There's 360 degrees in a circle. Let's just make sure this is working. There we go. We got ourselves a triangle. And let's put in the 5-sided polygon. There we go. I drew the triangle, then I drew this 5-sided polygon. So essentially what draw polygon does, okay, it takes a number of sides to draw. And so we're going to do this by the number of sides. Remember, for a square, we were just doing it 4 times. Now we can do it any number of times that we want. We're going to go forward by size, and then we're going to turn 360 degrees divided by the number of sides, because that's going to tell us how far to turn each time in order to draw that polygon. Okay, so now, instead of calling square in draw flower, we need to call polygon. And it needs to be number of sides and the size. So now, draw a flower. Draw a flower. It takes a number of sides, okay, and then a size. Or draw a flower takes a number of sides and a size. So let's see here. Let's do. Well, let's do 5 sides and a size of 300. Oh, size, angle. Oh, we got to try. Oh, okay. So draw a flower actually needs to take the number of sides, the size, and the angle to turn each time. There we go. So draw a flower is going to take the number of sides, which is going to get called when we do polygon, the size to draw it, which is going to get called when we draw a polygon, and then the angle to turn each and every time we're done drawing that that shape, that polygon. Okay, let's give it a try now. Oh, there we go. That's cool. All right, let's go with something like instead of turning 20 degrees, maybe 7 degrees each time. Oh, that is neat. I like that. I like that one a lot. All right. One of the last things we're going to do is we're going to add color to our polygon. Okay. What we're going to do is we're going to cause it to draw each and every single polygon in a random color. Okay, a random color. So we've got this random module. Do you remember when I told you about the pen color? Okay, that it takes 3 numbers, the amount of red, the amount of green, and the amount of blue. Well, up here, what we could do in Polygon, so we draw each and every polygon in a different color. Okay, we could generate using the random module, and I'll explain this in just a minute. Red, green, and blue. Okay. One other thing, you'll notice when I do stuff like equals, I put a space here and here, and like over here I did a space there and a space there. Those are actually optional. I just do them because I think it makes it easier to read, but you don't have to put that space there. Okay. So here's what's going to happen. When Polygon gets called, our function Polygon, the first thing we're going to do is we're going to make a variable called R. It's going to stand for red. And we use the random.randInt function, okay, from the random module. The random module has a bunch of functions for doing random things. And what this says is, hey, let's get a random number, generate a random number from 0 to 255. And then we're going to make a variable called G, and it's going to generate a random number between 0 and 255. We're going to make a variable called B, and it's going to generate a random number from 0 to 255. And then we call our pin color function, t.pinColor, like we do over here. Where is it? Not t.pinColor. And we're going to pass to it our R, our G, and our B, our red, our green, and our blue value. So now, let's see what happens. Oh, I've got an error. What have I done? Oh, random is not defined on line 6. Python variable, or excuse me, Python error messages are usually pretty easy. I'm going to trace this all the way down to the line that it says just before random is not defined. That gives us our actual error. It says line number 6 in Polygon, in our function Polygon. So let's go to line number 6, and sure enough, there we go. Random. Of course, I'm totally doing this on purpose to demonstrate this to you. Oh, there we go. It's starting to look really cool now. All right. So what I like to do, let me once again get rid of all this. Okay. Now we could do really neat stuff. For example, in here I could do something like, watch this, for x in range 3, let's do this, size equals 50. So remember, this is the number of sides to draw and the size. And what I'm going to do is I'm going to say size right here, comma 7. But each time through the loop, I'm going to make size bigger. Size equals size plus size times 0.2. So our shape will get bigger by 20% each time. We're saying, hey, let's make a box in our computer's memory. We're going to call it size, and it's going to hold the number 50. So the first time, and I don't need this t.pinColor anymore because I'm setting the pin color up here in our function. All right, so we're making it size equals 50. We're saying for x in range 3, so we're going to draw this shape 3 times. The first time through the loop, we're going to draw a flower, 5 sides, with a size of 50. Okay, and we're going to turn 7 degrees each time. And then we're going to say, hey, the next time we come up here and draw, size is going to be equal to size plus size times 0.2. So the next time it's going to be equal to 50 plus 50 times 0.2, which is what, 10? So next time it's going to be 60. So let's run this. Oh, that is cool. That is really neat. Let's make it a little bit bigger to start. And maybe, watch this, this would be cool. Plus, we use our x value, x times 3. Oh, wow. All right. So that's pretty much it. That's a basic introduction to Python and to turtle graphics. I hope you understood it. I hope that, let me make this smaller so you can see the whole program. I hope you understood it. I hope you get a little bit out of it. The best way to learn how to program is just program. Take this program, experiment with it. If you don't understand the whole thing, go back to the beginning and find a version of it that you do understand and just start experimenting with it. The best way to learn to program, the only way to learn to program, is to actually program actually write code. You're going to make mistakes. Things aren't going to make sense at the beginning. But just stick with it. And one of my favorite ways when I'm learning something new is just take something and just start modifying it. Take something somebody else wrote maybe and just start modifying it and changing it, and then you'll internalize the way it works and how things work. And if you have any questions or any problems, just put them down there in the comments. And before I leave, I'd really appreciate it if you subscribe to the channel. If you liked the video, I would really appreciate it. So thanks a lot. Today was a great day to learn how to code, and I'll see you next time. Bye-bye.